All right, looks like we're up. Make sure I have sound. Maybe, maybe not. That sounds like sound, right? Okay, cool. We have sound. We're good to go. All right, I'm back for a second stream today. This is definitely the most I've ever streamed in one day. 4 hours in the morning, and I'm going to try and do another 2 hours now. Pretty excited about where we left off. Basically, let's see here, how much to summarize. Let's just quit. If you want to find out more, look at the last stream for the details, but the basic idea is that we're going to we're going to take our symbol nodes, which currently look like you can't see what I'm talking about. Hang on. Which currently look like this, so A equals B, or some more complicated thing. It's currently a tree structure, so this is currently would be something like A, and then have B, equals, and have A and B as children. And I think this is bottlenecking a bunch of performance because of how it's laid out in memory. It's a bunch of pointers, and also there are a bunch of operations on this that end up being recursive. And I think we can get rid of some of that recursion. And so the idea is to restructure it like this, and actually it's going to be more like this, where now we just indicate where the parentheses are in the structure, and we indicate where each of the labels shows up, and then we keep around some notion of what the label actually maps to. And the nice thing about that is that we have a lot of the most commonly used, like the hottest paths in SymbolNode currently are things like this stuff. So like replace by name, replace symbol, replace all, finding nodes, are nodes contained, also a lot of like subtyping stuff, and getting out substatements, and all of those things I think don't have to be recursive in a binary tree world. Which I think should be a big deal. So let's see where we are. So we created a new type, and we set up how we convert from a symbol node tree from a symbol node to a binary symbol tree. Let's go ahead and do the inverse also. So we're testing into, okay. And then let's go and do assert equals expected dot into, what do we want to say? A equals A. So expected dot into, and then A equals A. And I imagine this needs to be cloned. Although I'm not sure. And so now we're going to need a symbol node. We need impl from symbol node, no, binary tree node. Binary symbol tree for symbol node from and okay. So how do we unpack this tree? Kind of like parsing. I definitely want to have this direction though, because it's also going to make testing so much easier. Just trying to think if I need to have a little parser for this. Or a little lexer, really. I read something in the docs on bitvac that it could be munched from the front. What is that? Munched. Bit slices could be munched from the front. It's the only place it says it though. Head rest. Okay, but I guess the easiest way to do it is just recursively is the easier way to do it. So if we do tree, let's see here, self new tree.getRoot. Tree.get children dot map dot into iter iter dot map child dot into dot clone dot into dot collect. And then this and so then we need a get root. And like the fact that this is recursive isn't a big deal because it's building a tree. What else is it going to be? It's got to be recursive in some sense. So get root. I was thinking about get root as one of the things that gets slower. SymbolNode root. Maybe it's not that much slower though. Like the basic way to do it is just self dot trees dot iter dot filter probably first find so there's going to be label and encoding. And then you say encoding and bitvec of 1 that goes this way by encoding.length. There might be an off by 1 error there. Dot expect there's always leading. This reminds me, we should goals. Binary. Flesh out methods for binary. Binary symbol tree. And then it's going to be to benchmark it. So we'll say against SymbolNode. And then we'll say update important call sites to use binary symbol tree. So plan for the day. Might not all happen today, probably won't. Okay. And while we're fleshing this out, we're going to ensure that binary symbol tree and SymbolNode can be interchanged. We're going to validate binary symbol tree to ensure certain constraints are satisfied. For example, all encodings have equal length, no empty encodings. Okay. Cool. So we go and we find this thing, and there's always one there. And then what do we do? We need to spit out its label. So map label, we don't care anymore, and label. Oh wait, this is going to return an option to the, so this just is the label. So let label be this. Whoa, what just happened? Label be that, and then throw a semicolon in there, and then self dot nodes dot find iter dot find label root label, can't say that, L root label equals L dot expect nodes and node trees have the same keys. And that should just get me back my root going to be like this. And then this will just be dot 0, dot 1. Okay. That should give me the root that I need. Expected symbol node. We got to clone it. Yeah, clone it. And the closure takes 1 argument. Is it a key value pair? I always get confused as to which ones take 1 argument and which ones don't. Okay. Can't compare string with, yeah, I thought I might run into this. Okay. So that'll give me the root that I need. And then I need get children also. So get children. Vec of self. Yeah, and this one isn't so exciting either. It's kind of recursive. Not too bad though. Can it just be like while let some child substatement equals self dot get substatement I let me to return equal vec nothing to return dot push substatement to return I plus equals 1 and let me equals 0 and then get substatement self I usize let's call this child. And it returns an option self. And so the way this should work is what? We gotta find the paren and then pop it open. So it's gonna be like has children is just self.structure and bitVec1 self.structure.length -1. I think that's cool. So this is going to be if self.has children, that has no children, then return none. It's weird that we kind of want to walk this vector from the left a lot. We might want to use the most significant bit structure, but whatever. They said it can be munched from the front though, so it feels like it should be fine. Okay, so we know it has a paren then as its second thing. So can we do like 4 index? Brian 0 index. How do we want to do this? So we typically will have something like 1 1 0 0 0 1 0 1. We'll have something like this. So this will be like y. So this will be like f of a, b, b, c, d. Is that right? think we should probably add one more test in here. Now that I'm looking at it. Let's go equals B equals C. So A equals B equals C. So we're expecting equals. Shoot, did this all just change? No, good. We're expecting expected nodes A, B, no, this would be 1, and then get children. No, sorry, 0, 0, get children 1. This is going to be 0, and then this is going to be C, and this is going to be 1. This is slightly tedious. Okay, expected structure. Okay, so it's A equals switch B equals A B C is what we want. So that's 0 1 0 1 0 0 1 0 1. So equals is going to be 1 0 1 0 0 0 0 0 0. Okay. 1 0 1 0 0. No, it's like this. 1 2 3 4 5 6. Should have 9. Yeah, 9 is correct. Okay, and then A, B, C, and these are all 0. And this is a paren. This is 1. This is a 1. This is a paren, and this is a 1. Yeah. Looks okay. Okay. Type annotation can't satisfy. Let's go back to tree and let's throw a to do in here for now. Okay, and yeah, I just want to make sure a more complicated example still works, because I'm realizing there's definitely stuff that wasn't really being tested. No, what's the problem? No implementation. Why is there no implementation for this? See, this bothers me. Can I end them together at least? Okay, I can, but encoding could be... No, I can't. Use bitwise operations on bit x, like bit some bit back and one some bit back dot length minus one. They don't inherently support it. Ugh, seriously, I have to implement my own. Why? That seems terrible. There's something called shift left, so at least okay, and then and does it? Seriously? This is annoying. This is annoying. What to do here? What to do here, what to do here, what to do here. I would really love it if these things would just implement binary operations. I don't really understand why they do or they don't. Transport protocols. Bit slice. Bit slice. View bits. Okay, is empty is a thing. First is a thing. Okay, get is a thing. So we can say encoding.get coding dot is it left or right indexed? It's probably left index, right? So this is just a 0. There's always the element. Can't compare a bit ref with an integer. And what's a bit ref? This definitely feels a little bit clunky. Okay, sure. We just care about the encoding. Yeah. So, same thing. It's gonna be just self.structure dot get one dot is sum. Yeah. Like literally, it's just not self dot has no children, which is has no children, and that's self dot structure dot length equal is less than equal to 1. Right. I believe it seems to be what's the issue? Type annotation needed. Okay, that one's easy. Let's just kill it for now. And go cargo test again. My computer is working very hard at the moment for no particularly good reason. I guess it's streaming and compiling. Maybe that's a good reason, I don't know. Don't know. Like compiling's getting slower. All right, that's cool. That passed. Can't say I was completely sure it was going to. Expected as SymbolNode, and then let's expected as SymbolNode. SymbolNode be this. this to fail because I haven't implemented everything. And let's not sit around and wait for it. Let's go implement it. Get root. Not that. Get root, get children. Okay. So back to this. Let's use the direct function. So it should be true that self.structure dot get one dot deref as deref should be some true. To say okay, let's have that helper function that says get structure bit or structure bit. Good. Structure bit 1 should be true. Let's go function get structure bit self index view size presumably bool self.structure.get index dot as deref equals some true. I guess we want to make this an option and go match this none some ref or some r bool ref ref equals true. Like that. And then get structure bit say assert equals some true. At least gives us some semantics back. Okay. So now we're looking for the ith child. So let's do something like while some let's do something like let mute I equals 0 for I in 0 index. Self.get child at let mute test index is 2 test index test index let's do a match and then let's say if we do get matching paren this let our paren index equal this test index equals r paren index plus 1, and then if we get this far, then we say some self.get child at test index is what I want. Yeah, that's right. And then this will be, if it's none, then there's no parenthesis there. So in that case, it's just test index. Otherwise, okay. Get child at self index binary symbol tree index option self, and here we say if self dot get structure bit index no, it's just let our match self.get matching emphasis index none then that means it's just this one item. This is, I don't love this. love this. Okay, so we checked it as children. We walk. Binary symbol tree index, and we say option binary symbol tree index, and we say if not self dot is structure. That's the problem. Get structure bit. Ew, no. Windows, go away. Dot get structure bit index, then none. Otherwise, for I in index plus 1 through wherever, let's just say let mu I be index plus 1 while bit equals sum true, while sum I is self.get structure bit I, while sum doesn't matter. In fact, you just say get structure bit dot is sum. I would just match self.get structure bit index plus 1. And then if it's none, that means that there's no structure bit at all, and we have a problem. But we return none. And probably warn. Warn. This should never happen. It is unbalanced. Some true, some false means that it just is the child. So then we want to say match self.get structure bit index plus 2. If it's none, we say the same thing as here. If it's some false. Then we say warn expected right parenthesis. We didn't find one. And if it's true, then we return index plus 2. And then if this is true, then we return self dot get matching parenthesis of index plus 1. Alright, let's name this pub type binary symbol tree index is a usize. And what's the problem here? Okay. Okay, and so now we just want to take the substring. So what if we do self dot step away for a moment and think about this. Okay, so I think I want the ergonomics of this to be gonna say I want them to be I give you a left and a right parenthesis and then just get back the sub statement. Which I do think is basically what I want. Get matching parenthesis. None. Then it goes from index to text index. So text index ends up being so now let child index equal test index. And now get substatement subtree at child index. We return that, I guess. Get subtree self index binary symbol tree index, and it returns a self. And this is going to be let's see here, match what are we going to want to do? Let subtree start equals index, let subtree end equals match self. Let's just say if self dot get matching parenthesis index dot unwrap or subtree start. Let structure equals self dot structure dot we want to get a slice. How do we get a slice? Dot get subtree start subtree end. Should probably be +1, right? No, probably not. Subtree end +1. Don't expect. We know that the ranges are okay. Do we know that? Not necessarily. We could put a bad index in here. Assert index greater than or equal to 0. Okay. Trees be self.node trees dot iter.map tree tree.get subtree start subtree end +1 dot expect. We know that the ranges are okay. This thing dot get subtree start subtree end. And we want to filter this, right? Tuple? Oh, yeah, fair. Label tree. Dot filter label tree. Tree is empty. Dot collect. Is empty what I mean, or is 0 what I mean? Those are probably different things, right? Let's find out. Is empty. Empty. Oh yeah, that's definitely not what we want. Is empty. Length 0. That's probably different than if the number is 0, right? Not any. Not any. Wait, is there an any? Yeah, there's an any. Okay. So I want to filter down to tree.any. Mismatch types. Label. Okay, and then what's the other thing we need? Oh, the nodes. So let nodes equal self dot nodes dot iter dot filter node. Let's see, label root. Trees dot contains key label dot cloned dot collect. Right, something like that. Unexpected token. What's wrong with my unexpected token? Oh, right, and then self new nodes structure trees. get subtree. This presumably needs to be an option. And that way we can say if index is less than or equal to 0, none. Here we can say match this. Oh no, that one we're fine. This one, match none, return none, sum less than s, okay, then sum this. Type annotations needed. We need this to be a hash map. And here we need it to be cloned. Bounds were not satisfied. Why? Filter any returns a bool, yeah? Any returns a bool. Okay. So label tree goes in, label tree comes out. Label is gonna be, I just clone it here. Here the type of trees is inferred to be something with a bit slice. Clone it here as well. Okay. And now probably this. No. Problem. Borrow. Okay, yeah. Didn't I just do that? Tree bound. Get rid of that. I don't expect to need this though. Why? Contains key. Or string to bit slice. It needs to be string to an actual bit slice. So So we're in a bit slice. As bit pointer. As bit vec. Clone from bit slice. It's not really what I want. I want it to get me a bitvec back. How do I get a bit back? Two bit back. Is that a thing? Seems to be a thing. Great. Oh, okay. This is what I would expect. What is the problem? Nodes contains key. Contains key. Label. I don't understand why I have to dereference the label, but do it this way. Love fighting with the borrow checker. Need this to be a hash map of binary symbol, no, of symbol name to bit vec of some type that I don't want to bother telling you. Oh, yeah, that's right. Okay. SymbolNode root. type, expected type, found reference 2-bit back. Okay. Can't move out of that. Fine. Clone it. It's gonna need to be cloned anyway. That's a fair point. Also a fair point. One other thing I want to do. Tree is on. We do new. I want to do self-validate properties, node structure, node trees. Do I want to bomb out of this? Validate properties. Function, validate properties. This stuff. Let length be structure dot length. Is length a thing? Length is a thing. Okay. Assert that node trees dot iter dot all, not this, tree dot length equals length. Assert length greater than 0. Anything else to assert here? Oh yeah. Let mute sum keep it back. We'll just say structure dot clone for tree in node trees dot iter. Some insert sum and tree. I'm not allowed to do this, am I? Not any, not all. Rotate, shift. I'm really worried this isn't going to be fast at all. Like if I can't use bit operations, then what are we doing? Probably supposed to use big int. Alright, let's look at big int's documentation. Num big int. Num big int. Rust. What do I want? I want to ensure that these have so if I look at big int, big unsigned int, can I do bitwise operations? Please. Bits. Bit and, yeah, this has it. Okay, I think we use this instead, which is annoying. Cargo remove. What was I using? Bit vec. Bit vec. Cargo add. Big int. Non-big int. Big int. Create a toml. Version equals features equals array. Okay. So now these are going to be big U int, like that. Oh my god, why would it be like that? Don't love it. Okay, am I using a prelude or am I just using use num big int big U int? Why is the I not uppercase? That seems real bad. Tree. This is going to be a big U int. This is going to be a big U int. Big U int. You know what I'm going to do is I'm going to rename this type to be pub type binary encoding equals big U int. And then we'll just go big U int binary encoding. Binary encoding. Binary encoding. Okay, these are going to get a lot simpler. All right, this is better because this is just bit. Bit returns whether a bit in the given position is set. Okay. So it's like this. And here it's so I want to get a subset of the bits. Okay, I'm trying to figure out if there's a better way to do this besides just getting a range of bits. Seems like no. Okay. These guys. I think we just want this. Okay. Cool. So now this becomes get bits range. And this is self get bits range tree, this, and this, and those don't matter anymore. Okay, this seems a lot better. And this should be the uint binary encoding. Okay. Don't need to match anything. Man, my computer is dragging right now. Okay. Okay. Non-primitive tab cast. New. From bytes. Didn't I see a whole bunch of assignments? From. There are a bunch of froms. From is fine. Binary encoding from. No one or anything we can use. Oh wait, there's a one. It's imbold though. Oh. Yeah, it says one is a thing. Binary encoding. One. Why was it saying it wasn't a thing before? No function or what? Items from trace can Okay, what's the trait? 1 num traits. Use num traits identities. 1. Cargo add num traits. Validate properties. Don't actually need all of these. So that's fine. Unused variable. That doesn't seem right. Maybe it is. Not equal to 0. That's what we want to keep around. Can't compare big U. Oh my god. Okay, fine. Binary encoding 0. There's 1. Docs. Right, types work. Fine. Fewest bits necessary. That's actually not what I want. because it can have a leading 0. Okay, so that ends up not really working. There's not really a thing. But what we do want is that the sum plus equals tree, and then at the end of this we want assert equal it should be a power of 2 at the end of the day. Iter dot all label tree dot tree is greater than 0, or yeah, greater than 0 is fine. That should be true. And sum plus 1 should be a power of 2. What's the nicest way to check that? Iter digits. Least significant digit first. Fewest bits necessary. Exponent. I don't really want to actually compute this whole thing. Do I have to? Can't I say assert equals sum plus 1 to check the sum plus 1, and then check should be equal to binary encoding 1 done sometimes. So the point is that the sum, which is really a sum. No, it is a sum. So the point is that there should be a 1 in exactly 1 column of the structure plus all of the trees. And so if I add them up, I should just get a thing that's full of 1s, which is the same thing as was no implementation for that. Oh, it said this is definitely not right though. I gotta go in couple minutes. Let's see here. Assert to check the bit 0 should be set. And then what happens if I, let's see here. That's not bad. Binary encoding 0. Binary encoding. Is the problem? Good. Alright, well, whether we're good or not, I gotta go. Ooh. Oh, I have a bunch of bitbacks lying around. Alright, we'll pick up there next time. Thanks for watching. Catch you later.